So now we've installed Numpy, we're ready to go. We're going to have a look at data types in this video. So we met our 5 basic data types that we had in Python: strings, integer, float, boolean and complex. And just to remind ourselves, an integer, just using a very basic variable name of I, set that to an integer, ask it what type it is, and it tells us it's an integer. So Numpy has got double the number of data types than Python has. It has the same ones and it has a few extras, which is really useful. So it also has an integer. In Numpy, everything is in arrays. So we set our variable to being a Numpy array of 1, which is in reality looks identical to, if I'd have printed that one out, let's print that out. There we go. So identical as far as we can see for what's printed on the screen. But if we ask about its type, this time we do the variable name, which is I.dtype. And if we execute that, it will tell us that it's an integer 64. So you can have different types of integers in Numpy. You can have int 64s, int 32s, and what that does is it tells you the type of data, the int, and the size of the data in bytes, which is your 64, your 32, etc. So the default one, if you don't specify anything, is int 64. But of course you can specify what type of data you want it storing as. So we're going to move to a different type of data, an unsigned integer, which is a U. So I'm going to set I equal this time to np dot, so using that numpy, U int 64, and let's set that equal to 2. So that is an unsigned integer, a value of 64 bits, and it has the value of 2 in this case. So if you look at its D type, it tells me it's an unsigned integer, 64. So if you need to, for some reason, specify, you can do just with using the specific flag for that type of data that you want to use, or you can just type in your value and it will assign something that's sensible. So that's integers, 2 types. For booleans, same as we had in Python, capital letter for the T, and let's straight away print out what that B type is. That's quite correct. It has no attribute type because that should be D type, please. And it tells me it's a boolean. Floats, same idea. You can set up a float. So let's not set this to a variable name this time. Let's print it straight out. So np array. Let's set this to 9.3. And let's straight away ask it what type it is. So you don't actually need to read it in to your code to be able to do that. You can do it in one line, and that tells you it's a float 64. We also have strings. So let's do the same again. Print np.array is a string. So it's in inverted commas or quote marks, whichever you prefer. D type is a U6. So this is actually a Unicode string. So it's a standard encoding system. There's also an S, a capital S for string as well, which is a slightly different string, which you could specify if you wanted. We can also do complex numbers. So our complex number, let's set up an array of 4.3 plus 3j. Remember, this is engineering based, so it's a J, not an I for your complex number if you're physics based. Print C, prints out my complex number for me, and if we check the D type as well, C.dtype tells me it's a complex 128. So you can see it's got more bits storing this value, which makes sense because that's quite a small 9.3 There's not a huge number of characters to store there, but we've got a lot more to store in a complex number. We also have objects. And this is a little bit of a catch-all situation where you can specify the type of data, the size and the byte order. So for example, it might be something like np.dtype. So we're asking the dtype of our object, which is going to be greater than I4. I can't assign that to literal because I hit 0 instead of an O. And this is specifying what you want here. So the greater than or equal to size is telling you whether it's a little endian or a big endian. You can also have a pipe, which means it's not applicable. And if you have no idea what an endian is, it's endiness. And the big endian stores the most significant byte at the smallest memory address, and the little endian is the opposite. So it's a way of storing data inside the computer. So have a look up endian if you want to find out a bit more about that. We can have a look at the byte order. So O.byte order. And that's telling me that that's our endian sign. We can have a look at the item size. Which is 4. And then the data type, which is int32. So we're storing an integer of size 4 with the big endian format for how we store that data. So normally, in most cases, you don't actually need to set up your own data type, your object type. You can just work with more straightforward data types in Numpy, but it's useful to know that they exist. Well, not quite the penultimate, but the next one is a V data type, and that is just a fixed chunk of memory. So that picks up anything that we've missed here, which you might be going, there surely can't be much, but you know, some data is very odd and you do need the ability to specify exactly what you want. And so we're going to finish with the last 2 data types in Numpy, and this is all to do with how you store date and time. So most of our number systems, certainly everything we do here, is based on the decimal system. It has a base of 10. Hours, minutes and seconds are based on 60, so the sexagesimal system. So they count differently. We would either have to convert everything into a decimal base to work in it, or use something different. And to be quite frank, the date is just a system unto its own. So we have a time delta and a date time system automatically built in to Numpy, which saves so much effort trying to work stuff out. So np date time 64, so that's our date time, 64 bits for storing it, and we can put our date in. So it's done the correct way round, done in ascending order of what changes the least. So the year changes least frequently, then it's the month, then it's the day. And if we run that, it's stored that into the system for us. So let's also add in a time here. So if we do np.date time 64, open brackets, open quotes. So year, month, day. Then we go on to the time, so we have a capital T, and then we have the hour, minute, second. And that works with the whole set for us. So we can do basic maths on this. We can work out the differences between two dates. And we can store dates in a sensible fashion. So if we wanted to work out what the difference is in two dates, so let's go with 2020-06-04 and see what the difference between that and 2020-06-03 is. Make sure you spell it date time correctly, and it tells us it's 1D, it's 1 day. We can kind of work that out quite easily in your head. If we just change that to 3rd February, then he tells us it's 122 days. So it doesn't convert it into a strange system for us. It tells us in days rather than months, which makes more sense. We can do the same with time. So if you want to know what the time difference is, we have time delta, again, 64 again, and we can specify. So I'm going to specify 4 hours. I'm going to take away time delta 64, 3 minutes. And the difference is 237 minutes. So each unit of time has its own identifier. So a year, a month, a week, a day are all capitals with the first letter. The same with hour, minute and seconds. They're lowercase of the first letter. Right, so there's a lot of different types of data. So 10 different data types you can use in Numpy arrays. In reality, what you'll probably do is just set it up as an array and use it. You won't need to necessarily specify exactly what you want to use, but you have the ability to do that now if that's something that you need to do. So that is our introduction to data types. The next video we're going to have a look at array types. So we're going to have a look at different types of array that we can use in Numpy. I'll see you there when you're ready.